All right, good morning, everybody. Thanks for getting up after what had to have been a rough night after seeing some of the other speakers.
This still feels like the middle of the night to me, so.
Oh, sorry to interrupt.
No, my battery is dead. What happened?
Don't worry, I'm running out of here in 5 seconds.
Dude, it's a Sony, it's not an Apple, you're cool. All right, guys, so we're going to be talking about Mona and Metasploit framework. I guess we'll go ahead and get started. I am Null Threat, also known as Elliot Cutright. I am a information security red team guy at Boeing. The big thing about this slide is everything we do in this talk is stuff I did on my free time, in no way supported by Boeing. They do not, they don't have anything to do with this. So if you get mad at me or Peter for something up there, don't go to Boeing because they don't care.
Yeah. So, good morning. My name is Peter van Eeckhoutte. Don't try to pronounce it. Corland Coder is just fine. I don't hold any certifications, so anything I say may not be true, or it might just be true. And so that's my Twitter handle if you want to follow me.
We are not the only two guys in the Corland team. There's a list of the rest. You can also find us at corland.be or in our IRC channel. We're pretty friendly most of the time, so if you guys have questions about the talk or anything, that's not true. If you guys want to come in and ask us questions or anything, feel free to join in the IRC, and we'll try to help you out in any way we can. The big thing with this talk is it's going to be slightly technical, so we're going to go over some different methods for exploitation with Windows 32 systems. So anybody in here not familiar with the steps for exploit development? Raise your hand. Anybody at all? Yeah. Thanks, J-Duck. Nobody else? All right. So everybody's an expert in here. I don't think we need to do the talk.
Yeah, if you guys know how this works, I mean.
All right, so for those who didn't want to raise their hand, if you're not familiar with exploitation, there's 3 general steps that we're going to talk about here. The first being triggering the overflow. Basically what we need to do is we need to make the app crash in some way. Step 2 is we need to control EIP and redirect it to payload. We need to get control of the application and make sure that wherever we're sending it, we have control of that area. And 3 is making the target do what we want. We need them to do
Something different.
Yes.
Something special.
So why do people write exploits? We get this question actually quite a bit. It helps prove a point. It can be used pretty quickly, pretty easily for if you need to show why this vulnerability needs to be, why you need to worry about it, other than, oh, the app crashed. No, the app didn't just crash. We can do a lot more with it. Some say you can earn money with it. I haven't seen it. I've never made any money off this stuff. So ego and recognition is a big one. People really like seeing their name on exploit database.
Yeah, but to us it's just fun and an intellectual challenge. So that's why we do it.
Oh, some people really like showing off their ASCII skills. If you guys go on exploit database and take a look, you can sometimes find exploits that are 100 lines of, hey, what's up? I'm sending my greets out to my friends. Here's my awesome title. And then it's 4 lines of exploit. We kind of have an example picture. These dudes of the Corland team throw tons of crap at the top of their exploits. As you guys can see, there's no code there. We haven't even started the exploit, and we've got like 70 lines. We gotta quit that, Peter.
Yeah, we gotta stop doing that. Well, so that was just an introduction. Let's take a look at some facts, some scientifically proven facts. And we'd like to quote research done by Dr. Lee and Dr. Rood. They presented their research at B-Sites in Las Vegas in the Long Bear's Guide to Exploit Development. And they basically said, we'd like to quote,
the standalone exploits suck. You guys, this stuff with this static crap, just putting in DLLs that don't exist on other operating systems, targeting ancient obscure OSs. I've seen so many exploits that are targeting like some weird Chinese version of Windows XP with no service packs, and they're throwing it up there and marking it as universal, which we'll talk about in a little bit. so many obscure scripting languages. You see them written in C, Perl, Python.
I've even seen exploits that like create a zip file and you have to use PHP to create the zip file. So now I have to install PHP to get this exploit to work. I mean, come on, guys.
And hard-coded payloads. So there's real risk involved in just grabbing an exploit and firing it off if you don't understand how it works. Some payloads just pop calc, some of them just, pop a reverse shell, some of them kill the cat, order 500 pizzas, and will steal all of your Dito bitcoins.
So what else is wrong with, standalone exploits? Well, we're not even sure if they are properly tested. I mean, it might work on their box and it might consistently work on their box because, they tested it a few times. But that doesn't mean anything. I mean, if you want to have a quality exploit that works in your pen test engagement or in any other situation, you've got to make sure that it's going to work. So it has to be tested on multiple versions of the operating system, multiple patch levels, multiple service packs levels. And only if you do that, and if you do that right, and if you actually test it on multiple images, and maybe ask your co-exploit developers to also test it, then you can label it as universal if it is universal. But we're just seeing too much exploits lately that claim that they are universal. But what if they are universal on XP Service Pack 3 and it's only your box? I mean, I don't.
Yeah, if you test it in XP Service Pack 2 and 3, don't mark it universal because it's still not universal. If it doesn't work in everything, it's not universal.
Yeah. So in terms of payloads, I mean, most people, they just want to show that they can execute code. So that exploit, it contains like a blob of hacks. We don't really what it is, and they just add a comment and say, okay, this is going to launch calc or message box. So you as a pen tester, you want to use that exploit in your pen test engagement. So what are you going to put in your pen test report? Is it going to look like this? Like, oh, wow. I spawned calc and message box on all your servers. I mean,
you're totally owned.
Yeah.
I can open calc on any machine in your company.
So even if you can execute code, even if you can spawn calc or message box, I mean, it doesn't really mean anything unless you actually try to put in bind shell or interpreter. I remember I've seen a couple of the students that were in the training the last few days, and these guys know that even although you can execute code, that doesn't mean that it's going to be a reliable exploit and that you will be able to use it to get a shell. So that's ultimately what we want.
Yeah, and these guys don't really go out of their way to make sure that the layout is the best. Most of the time you see people, especially people that are just getting into exploit development, they will throw together some Perl script or Python script that they've ripped off from somebody else, made a few changes to, and then they upload it to the exploit database just to get back to that fame. They want their name on there, and I was that way when I started.
Yeah, I mean, some people, they just write an exploit and use an egg hunter because it's sexy, but if you just take 5 minutes, you just spend 5 minutes looking at the exploit and you could just find a huge amount of space that you can use for your payload. There's no need for an egg hunter. So thinking about the payload structure and how you actually build that exploit is important for reliability and speed. So, and even more important, all the exploits on ExploitDB or proof of concepts, if we just leave them there, if we don't do anything with them, then this is what will happen to those proof of concepts. Pacman will come over and eat all of them. So we'll have to take them and basically do something with them so they can become value to us. We can actually use them in a real life situation. And that's basically the topic of today's talk.
So what does Msp have to offer us as exploit developers? The first thing is it's a very powerful framework. The Metasploit APIs and mixins basically make it to where we don't have to rewrite the same code every time. It gives us the ability to talk to the network protocols. We don't have to create all of those over again. We don't have to write all of the communication protocols, the engines. We don't have to write let's say we're going after FTP clients. We don't have to write an FTP server for those clients to connect to. Metasploit has all of that stuff built into the framework for us. So it speeds it up, and it makes it more universal. So my version of my exploit that's ready for Metasploit is going to work on your version rather than making sure you have Python 2.7.1 with this, obscure something over here, or this version of Ruby with this gem over here. It just allows us to quickly and easily create these exploits that are going to be portable across several operating systems now.
Yeah, we know that there are no Ruby issues with Metasploit, so it's fine. On top of that, Metasploit comes with tons of payloads already written. You don't have to write your own shellcode. Whatever is in there is most likely going to work. There's a whole bunch of encoders that you can use. It comes with, I don't know how many auxiliary modules I can use to find targets, do fuzzing, do all kinds of stuff. So
plus, it has the ability to check versions and make sure that if the service reports a version, that when you connect to it, you can make sure that the version that you're attacking is the version this exploit's written for, so that you're not crashing boxes when you're out on your pen test, hopefully. And a wide variety of post-exploitation models. So yes, you've gotten shell, wow, that's incredible, but thanks to the work of guys like Dark Operator, we have a huge number of these post-exploitation modules that'll help us get the information we want very, very quickly and put it in a format that we can use it and show value for the exploit and why exploiting that system is so bad for the company.
And on top of that, it comes with like more than 700 exploits right now, something like that. That's awesome because you can look at those exploits and you can learn from them. They are not only using the same language, so you will be able to recognize the structure, but you can just learn at how they implement or how they use a certain communication protocol, and what the syntax is that you need to use to write the exploit. So even if you are a total Ruby noob like me, you could just copy an existing module and start editing to convert it into your own module. So that's pretty awesome.
These guys go through a lot of work to make sure that the modules that are out there are high quality, are put in the right format, and I can tell you, we've heard over and over, they're getting tired of crappy exploits being sent to them and having to spend days cleaning up our crappy code. So we're hoping to help with some of the things we're going to be showing you later today, but definitely look at the exploits that are already there, because there's a lot of really good information on how to do things in that.
Yeah, and of course there's awesome community support. They have a channel on RC where people can just ask newbie questions to Josh, for example. He will be more than happy to answer them. We like the community. That's why we're here. So
don't ask J-Duck. He kick banned me once.
Yeah. You probably deserved it. So.
Oh yeah, Meterpreter guys. This is the coolest payload I've ever seen. So I think we have a comparison. Yeah. So this is the classic bind shell. It's kind of fat and slow, but look at that new sexiness. There you go.
That's what we want. Yeah.
Yeah.
So, just a few more words to try to convince you guys to stop writing standalone exploits and write Metasploit modules instead. So, just a few items. If you can learn how to write code in Python and Perl, you can learn to do the exact same thing in Ruby. It's just a different language, it's different syntax, but you can learn it. And if you actually try, especially if you start writing an exploit in a Metasploit, you'll see that it's actually easier because you don't have to write that entire file. You can just use a skeleton or an existing modules, and the number of lines of Ruby that you'll have to write is most likely going to be very limited. So that's actually not too bad.
If you're spending more time writing standalone,
no, well, actually, if you end up spending more time writing the syntax in Ruby, then you would be doing it in Python, then you're probably just doing it wrong. So.
Nice PowerPoint, slow down. Yeah. And Metasploit, again, exposes all those classes for making the exploit writing a lot easier. But one of the big things here is the, again, we're all doing this, or most of us are doing this for vulnerability assessment work. And so the time, the quality, the ability to select multiple targets and change our payloads without having to make huge changes to the exploits, it just makes it easier. It makes the code more portable, and it really pushes you to make higher quality exploits right out the gate.
Yeah, and if you're faced with a deadline during an assessment, you only have like 1 or 2 days to do a short pen test. I mean, I can assume that you don't want to spend all of the time trying to figure out why the exploit you took from exploit.db doesn't work. So time is important, quality and reliability have direct impact on time. And you also, because when you use Metasploit, you can, if that exploit provides it, you can actually use the same exploit, just the same file, and target multiple targets. You can use multiple payloads, so you do not have to go in and try to figure out, hey, what will happen if I take out this little nice calc message box and replace it with a bind shell and then try to figure out why it's not working anymore. So lots of advantages. Yeah, absolutely. And if you're writing your standalone exploits only to get them to show up on exploit.db, trying to make a name in the field, well, just write a Metasploit module, submit it to Metasploit, and it will show up on exploit.db and package store them anyway. They'll scrape, so that's not an argument either anymore. So in short, standalone exploits, well, they work.
They have features.
Yeah.
Kinda.
Not sure if we want these features, but I mean, this is what we want.
Those
this
are good features.
Real stuff. These
good
are good features. Yes. So enough chit chat. Let's take a look at your typical exploit development process. We usually start with something that just proves a crash. That it just shows that we can crash something. That's usually where we start with. The first thing that we'll do is try to figure out some offsets, like what are we overriding? Are we overriding a safety return pointer, an exception handler, a vtable, whatever? We try to figure out in that payload that we're using, what is the exact distance to actually override that specific location in memory. And we also try to figure out what are our options in terms of placing our payload, our shellcode, whatever, where are we going to put it? And if we combine those two, we'll have the answer to how are we going to jump to that payload. So,
bad characters, critical. Most people we have found wait until the last thing to try to go back and find bad characters. They'll throw in some payload and then they'll find that it doesn't work. And that's when they'll start trying to track down bad characters. We are really pushing this where you do it immediately after you've got your crash and you found your offsets, because when we get into ROP, having your knowledge of your bad characters is absolutely critical. Otherwise, you won't be able to start building your gadgets for ROP, which we'll be talking about here in a few minutes.
Exactly. And if you look on exploit.db, you often see a lot of exploits that just use a alphanumeric encoder payload. That's probably safe. It's probably going to work, but it's like huge. You can probably put a truck in there and you don't even see it. So, and that's kind of bad practice. It's highly recommended to figure out what the bad characters are. And like you said, it has an impact on ROP, and we'll talk about that later on in the talk. So, and then when we figure that out, we'll try to find a trampoline or a way to go from that crash and actually land in our payload. And there are a bunch of ways to do that. You could, depending on the exploit, you can jump to a register. If you have overwritten a exception handler, you can use some kind of pivot that will bring you back to your payload. Vtable function pointers, there's all kinds of ways that you can use to redirect the flow of the application to your arbitrary payload that you've put in memory. And also ROP, it's getting more and more important. We no longer have the luxury to just say, okay, well, DEP and ASLR and all that kind of neat stuff it's not an issue for me. I'll just continue to write exploits for XP. Well, hey, XP, it's still out there, but it's going away. We are starting to see that companies and especially end users, I mean, if you buy a new computer, it comes with Windows 7. So you'll have to deal with DEP and ASLR. That's a fact. So doing all of that, if you want to do it properly, it takes time. We all agree that that takes time. And if you don't have the time, if you are like many of us who have a family, you have children, you have a day job. I don't even have a day job where I do exploit development. So this is just stuff I do in my spare time. I mean, it's difficult to find that balance and to make sure that you have enough time to play without causing issues in your household, if you will. So yeah, that's difficult, and that means that we'll have to try to be as efficient as possible when writing our exploits. So we know that it's going to work in a reliable way, and it's going to be of added value when we want to reuse it later on. So if you don't do that, well, if you don't have the techniques or the knowledge to write good, efficient exploits, well, if you're lazy, you'll just say, well, fuck it, I'm not going to write a Metasploit module. I'll just go back to writing my crappy standalone exploit, insert my huge banner, shouts to everyone in Turkey and Iran, and I'll post it on exploit.db. It's fine, but I mean, you probably won't get my respect with that. So what can we do? And we, as a community, means all of us in this room. We can try to educate people. If people post an exploit or have questions about the exploit, well, force them to write a good exploit. Recommend, Kai, stop writing that exploit in Python or PHP or whatever. Try to write it in Metasploit. It might be a little bit painful the first time, you'll get better at it. And I mean, it will force you to write a better exploit, especially if you want to commit your exploit to Metasploit. Oh, they will just reject it if it sucks, basically. So.
And the other thing you can do is write tools and plugins to make this process more efficient, make it work a little bit faster, which is what you're going to see here in a few minutes. But the key point of all this is it's not a or, this is an and. You need to be out there educating. We need to be out there helping people figure this stuff out, and we need to be writing tools to help the process along. And speaking of plugins.
Yeah, well, there's plenty of it. So.
Have you guys ever heard of half of these? Because I hadn't. That's ridiculous.
Yeah, I just did a quick search on plugins for exploit development. There's a lot of plugins out there, and we are still seeing crappy code. So how come? That's an interesting question. Well, there are way too many plugins, and if you just look at all these plugins, some of them work for WinDebug, others work for Ollie. The older version, we're starting to see plugins for the newer version. Some of them are implemented as a script in Immunity Debugger. There's a bunch of standalone scripts. So that's kind of an issue. I mean, if you're writing an exploit, you're not going to use like 5 debuggers to write that specific exploit just because you want to use a plugin. It's kind of painful. Most of these, well, not most of them, but at least a good amount of these plugins, they are outdated. They were written like 5 years ago. They are not maintained anymore, and that also means that they are not capable of dealing with more current memory protections, such as ASLR and DEP. That's a big issue. In fact, most of these plugins, they're not even able to deal with rebase. It's an often overlooked issue with modules. It's a functionality feature. It will make sure that when a DLL, and a DLL has a base address, when 2 DLLs that have the same base address, when they get loaded in memory, the first one that will get loaded gets the correct base address, the other one is going to get loaded somewhere else. Now, most of these plugins, they'll just ignore the fact that the DLL, the one that got rebased, is going to be not reliable. If you use pointers from that DLL, they're worthless. It's pretty much like, well, to an exploit developer, that behavior is pretty much like ASLR.
Yeah, what it'll look like if the plugin isn't calling it out, it'll look like it got rebased due to ASLR, even though it's telling it that it's not ASLR, but it's actually just the functionality of making sure 2 DLLs don't get loaded into the same space. Yeah. A lot of these are also broken. They just don't work. Back to the outdated, poorly maintained, systemic issue in this industry. We write code to come up here and do neat talks, and then nobody maintains it, unless Metasploit picks it up.
I also hate it when you use a plugin and you actually have to tell it what module to query. I mean, so that means that you have to figure out what module you want to target, why you want to target it. I mean, that just takes time. You just might as well, do it manually and just use the built-in debugger search. I mean, anytime I see anyone looking for a jump ESP in debugger and do like, find jump ESP, I found one, I'm going to use that pointer. I mean, they should hang him. So I already mentioned ASLR and rebase. It has a huge impact on reliability, and it might continue to work in your box, but unless you actually test the exploit on other boxes, you will see that it will cause issues. So you need to, ideally, you need to have a plugin that is capable of detecting that and dealing with that. And if you are using tools that are not performing searches inside the process memory, so when you just do something, do a search on a DLL, well, what if the DLL is packed? And if you haven't noticed that it's packed, well, it's not going to return anything valuable to you. It might return pointers because it discovered like series of bytes in the file. It's going to return pointers, but it won't be reliable because the DLL is, the contents of the DLL are going to change as soon as it gets loaded and unpacked in memory. So basically, by looking at all these plugins and trying to figure out what to use, whether you have the skills or not, you'll probably find yourself making it harder on yourself than it should be. And we really need something that is better, faster, stronger, and ideally, since we are talking about Metasploit, it should be Metasploit friendly. So anything it produces should be, usable to be put and to be used in a Metasploit module. So, in February 2011, we started developing Mona.py. It's based on the extension. You can see that it's a Python script. It's actually a Py command for Immunity Debugger. It uses Python. And yes, if Immunity would have been using Ruby, I would have written it in Ruby. But it doesn't. I'll just put everything.
As you can see, pretty good sized file. I think one of the instructors I had last week for an exploit development class said this is one of the largest single Python files he's ever seen. I'd agree with that. The development started in February, released in June. We're currently a 1.2 dev. This is a full-on replacement and rewrite for PV find adder. So if you're still using that plugin, guys, please switch to Mona. Faster and a lot more functionalities we're going to go over. You can grab it at redmine.corland.be, and the manual is out there. Please read the manual. We're going to go over many of the features here today, but the features are all detailed and written down in the manual.
Yeah, and anyone says, I don't like Immunity Debugger, well, don't worry. We don't like it either, but hey, it has Mona, so.
We looked into doing like WinDebug plugins, and it was just a mess. Yeah. So this was the easiest and most ready to go. So. Mona takes a little bit of configuration to begin with. We end up with working folders, which is great. It's one of my favorite features because if you're ever developing exploits for multiple applications, what working folder will do is take Mona's output, which will come in a text file, and put it in a folder of your choice, designated by either the process name or the PID. As you can see, the variances there. And it will keep Mona from stomping over the logs before because it uses a standard set of logs and names. And so rather than, if you're working with this app, you've got your rob.txt, and then you go work on another app for a little while, it's not going to stomp all over each of those logs.
Yeah, and since we are performing searches in memory, we'll need to have the ability to exclude certain modules from the searches. If you have shell extensions loaded, or if you're using a VMware VirtualBox and you have the guest edition tools installed, they will load a DLL into the process memory. Guys, don't use a jump ESP from your VirtualBox or VMware DLL. I mean, it probably won't work on a physical machine. So exclude modules will basically allow you to specify a list of modules that are installed on your development machine and that you want to exclude from any of the searches that are performed by Mona. So back to the working folder. So this just pretty much what it will look like. It will create a subfolder or subdirectory based on the process name that you're working with. And then in that folder, it will show you the output that you're producing. So.
Another big thing is the use of global options. So these are options that you can use anywhere inside of Mona. If you want to exclude certain modules, you want to search in certain modules, you've got certain protections you're not worried about or you are worried about, you can go in and configure those. And almost all of the commands will honor these limitations.
Yeah, so you'll see as soon as we start talking about ROB, that's actually quite interesting. So I'll just skip through them real quick. So you can limit your search on just one module if you want to. You can also limit or restrict the search operations based on module properties. If you want to skip ASLR and rebased modules, you could just do that. And by default, the searches are set up with a set of default values. If you're looking for a pointer to jump ESP, it's going to skip anything that is ASLR and rebased by default. If you're looking for a pointer to pop-up red, it's going to skip modules that are safe SCH protected by default. So even in the default settings, whatever is returned by Mona is most likely going to be reliable to you. So you can also limit the search based on the properties of the return pointer. So a pointer consists of 4 bytes, basically. Well, what if one of those 4 bytes is a bad character? We need to be able to do a search and tell it, look, these are the bad characters. These are the bytes that we do not want in our payload. And it's going to skip pointers that have at least one of those bytes. You can also say, okay, I only want ASCII pointers, like pointers that consist of bytes that represent ASCII, printable, or ASCII, or uppercase, lowercase, upper num, alpha num, Unicode, numeric, doesn't matter. There's a bunch of stuff that you can tell it to look for, and that will help, getting the pointer that you need.
And Mona has nice built-in inline help with a lot of these options, and then the Mona manual also goes into more depth on all this stuff. So now we've got, we're going to get into some demo stuff. So great thing is we found a proof of concept on exploit database for an application that one of our customers is using. We're doing a pen test. All we get with the proof of concept is a zip file with some files in it, and we need to basically create an exploit, reliable exploit out of these files. So Mona's got some features. In this one, we're going to be talking about, it was a MKV exploit, isn't it, that we're going to do the demo on? Yeah. So basically, we downloaded a zip file. It's got an MKV in it. We ran the Mona header. That will give you a very easy, Metasploit-friendly output to automatically generate your file headers for you, and you'll see that here in a second. We also have this Mona skeleton built-in option that will allow you to generate Metasploit modules with the proper mix-ins to a point for file format flaws and TCP UDP clients.
Yeah, and I'll probably add like support for web browsers and some other protocols. So this is just like what is in there right now, proof of concept, and we'll expand functionality. So these are the 2 basic steps. Imagine you have a proof of concept. You don't have any code. They just, you downloaded the file from ExploitDB and it just crashes the application. How do we turn that into a Metasploit module right away so we can start building the exploits in Metasploit? So quick demo. So it's a Winamp bug, and it's actually our friend Luigi. He found it. So let's take a look.
Yeah, the big thing with this, guys, is this is real time. So you just see here, we went out to exploit database, and we just found this bug. And it's a zip file. We'll go grab the zip file. Open it up. The zip file is going to just end up containing several proof of concepts. We're going to grab the first one, is the one we're interested in. So
we will simply read that MKV file with Mona header. It's going to read all the bytes, and it will show you the Ruby commands that will allow you to recreate that entire file. This is a proof of concept, so that means that based on that, based on those Ruby commands, we might even be able to spot, see the last line, A 16,344s.
I bet that's the overflow.
Yeah, that's probably what triggers the overflow. So then Mona skeleton, it will ask you file format, what is the file extension, it's MKV in this case, and it created the file msfskeleton.rb.
So what you'll notice here is it's going to launch. It's got all of your header information for you. It's all generic information at this point, but it's all there in the proper format, ready to go.
Yeah.
What we're going to do is paste in that header file that we've just created, and we're going to make a few changes to it. We now know how many A's it takes to overflow, but sending a bunch of A's aren't very useful. The cyclical pattern is definitely more useful when we're trying to find our offsets. So just make a few quick changes here so that we generate the file. And now we have a working Metasploit module to create that proof of concept file in like, what, 45 seconds, something like that?
Yeah. So as you see, I'm using Metasploit on Windows just for the sake of this demo, you'll see it loads super fast in my system. So this is just real time, and we didn't edit it so far. So.
So now we're getting ready. We're launching Metasploit.
There it is.
And now what we'll do is we'll go ahead and we'll just start using the standard Metasploit commands. We're going to use exploit file format, winamp, POC. We're going to set our payload. Check the options, and then we're going to, okay, so we see where it's going to create msf.mkv, run the exploit. See, there's not one there already. We didn't put one in the oven and have it ready to go. So now we have our MKV file, and this is basically going to just be the exact same thing that we got from the exploit database proof of concept, except we added the cyclical pattern, and we've used Metasploit to create it rather than Python script or something else. So we look for winamp, attach. Again, no editing. All right, so we've attached, we start the process, and then we're going to go open that MKV file with winamp. And
boom.
Access violation.
So we have been able to reproduce the crash, and we are using cyclic pattern now, so not just ACE. So we control EAX, this is a call, EAX, so
there in 2 minutes we took a proof of concept file off exploit database, fed it into Mona using 2 different commands, and now we have a working Metasploit module to recreate the exact same thing that was on exploit database.
So the next step usually is, now that we have a crash using a cyclic pattern, we'll try to find the offsets. And what most people use is pattern create to generate the cyclic pattern, pattern offset to actually get the offset. So we've implemented similar commands, and they basically use the same routines as in Metasploit. So you can use Mona PC as in pattern create to create a pattern, and you can use Mona PO to get the offset. Now, Mona also has a find Msp function, and what the find Msp function will do is it's going to look at all the registers. It will detect the registers that are overwritten with a Metasploit pattern or point at a part of the Metasploit pattern, and it's going to give you the offset to that register, to that location in the pattern. That includes EIP, of course. It's also going to walk the stack, and it will look for locations where it can find the pattern. It will also look for locations where it can find a pointer to the pattern, and it will do all of that whether it's just ASCII or if it has been Unicode expanded. So it will also find the patterns that are Unicode expanded. And on top of that, it's also going to show you every single location and memory where it can find the first 8 bytes of the pattern. So we are used to looking at data on the stack, but if, for example, you're exploiting some kind of network server, it's not that uncommon to see that if you send a packet to the server, it's going to get read into the heap first. We don't know how big the packet will be. It will be read somewhere, and then it gets processed by the application. It might trigger a bug while trying to copy something onto the stack. And what we usually look at is, can we find our payload on the stack? It might be truncated. It might be converted to uppercase or Unicode or whatever. There might be a bunch of reasons why that payload looks bad on the stack, but you think, hey, that is the only location where I can find my payload. Well, find MSP, it's also going to show you all the other locations where it can find the pattern. Maybe there's a copy in the heap that is not corrupted, and if you combine that with the last bullet point, it's also for each pattern that it finds, it's going to show you the size of the pattern that it could find. So you can easily see what your options are, how much space you will have, and of course the size or the maximum size is purely based on the size that you used in your exploit. You may have to go back and increase or decrease the size to get more accurate results, but at least it should give you like a first impression of what your options are. So highly recommended to run find MSP right away.
All right, so we're going to kind of get through this because we're running short on time. So Mona can also help you find bad characters. There is a video demo of this on the manual. Mainly, it's important because of ROP. We can load a full byte array into memory, do a trigger the crash, compare what we loaded into memory versus what was loaded into memory versus what we sent it, and it'll basically start spitting out through that process. This is a bad character. This is a bad character. This character got turned into this character. It used to be a really manual process, so it's really sped things up.
Yeah, and the reason why we mention ROP all the time is in classical exploits that didn't have to bypass dep, we usually ended up with just one pointer in the exploit. So finding a pointer that didn't have any bad characters was more or less easy to do. With ROP, a bigger part of our payload are pointers. So we need to have the ability to, when we are looking for gadgets, to already filter the gadget and make sure that they don't contain any bad characters. So.
All right, so we're going to take a look at using Mona to find offsets and options, find the jump for us. But at the end of the day, what we're really interested in is Mona has all this capability. Can we automate things? Using Mona Suggest, we have the ability to use the cyclic pattern to find where it is, find how much space we have, find the correct jumps to make sure that we can pretty much go from proof of concept to a working Metasploit module in less than 5 minutes normally. So we have a demo for that here.
So this is our little proof of concept script that we downloaded from ExploitDB. It creates a little playlist file, 2,500 A's. So we'll just simply create the file. And again, all of this is real time. So we're just showing the process of going from a crash to a working exploit.
So we're going to try to load it up. We've caused the access violation. We have control of EIP with our A's. So now we need to have Mona take that file, create our pattern. Mona outputs everything into that log file. You will see it in the log area under immunity, but it truncates it, so be careful. Don't trust it wholly. So it's going to be easier for us at this point to go ahead and just put the pattern into the Python file and fire that off. Because with Mona Suggest, she'll go ahead and take that and build out the proof of concept much quicker.
Yeah, so it's important for this functionality to work that you actually trigger the crash with a cyclic pattern. So Mona can run the find MSP in the background. It can determine what type of exploit you can build out of it. It will look for the necessary pointers, and it will create a skeleton file. So we still control EIP. We'll just run Mona Suggest. And we'll use -n. We kind of figured that this is a playlist file, so we'll probably want to avoid null bytes, 0A, 0D, and so on. So that's kind of...
And it's kind of the same query that we got out of Mona Skeleton.
Yeah. By the way, you saw the ExploitDB screen. If you're porting an exploit off ExploitDB, you could just fill out the number. It's going to grab the title, the authors, and kind of fill that in automatically for you. So.
All right, so we ran Skeleton, went through the process. It has generated the file for us. So if we go in here, we'll see our exploit.
So file format, we can see bad characters. Yeah, so we kind of figured let's play safe. Let's add a bunch. This is just for demo purposes. You should have done the exercise to find the bad characters. See, it found a pointer. It filled out the offset. This is pointed to jump ESP from that DLL. It's not an OS DLL. It tries to use an application DLL. And this is the structure that it could determine based on the cyclic pattern. So we'll just put the file in Metasploit and we'll test it.
So we're going to go ahead and just reload Metasploit here. And yeah, so I mean, this has been about a minute and a half. We've gone from proof of concept online to hopefully we'll be able to get shell or calc off of this in less than 3 minutes. It takes a little bit on Windows. All right, so it's generated the file. We're going to go ahead and go load that file up. See, it's right there. Open the file. And calc. Calc in less than 3 minutes.
Yes. Well, I could have just start run calc. Yeah. Anyway.
Yeah, there are easier ways to get calc running.
Yeah. Something similar also works for exception handler overrides. So those are kind of the two classic exploit techniques that you can basically automate, and you can create in a Metasploit module in an automated manner. So with Mono SEH, you can look for pop-up red pointers for yourself. You can also trigger the crash with cyclic pattern and use Mona suggest, and it will detect that if you have overwritten an exception handler, that it needs to build a Metasploit module that supports that kind of exploit. So.
And it does it all automatically.
Absolutely. So Unicode, it has nice support for Unicode. If you ever have to deal with Unicode exploits, finding a pointer is fun, it's interesting, challenging, especially if you cannot find any pointers that look like this, like 00 byte, that will bring you to your payload. But we may be able to take advantage of conversion. If you look at the pointer 004721201E, what if that pointer points to your jump ESP or pop-up red? Well, it doesn't look like a Unicode pointer at first sight, but it actually will get converted to that pointer if you use 4784 in your payload. So if you have to do that manually, I mean, guys, good luck. Mona will just, if you look for jump ESP, it will just give you that information. It will say, you can use this pointer, and it will get transformed into that location.
So we just got the 5-minute warning, so if we're going to get to the last demo, we're going to have to kind of churn through this. Mona supports egg hunters, ASLR and rebase. All these slides will be online. So
yeah. So quick summary. This is the stuff that Mona does to help you out with building exploits for Metasploit. So Ruby output, we try to create Metasploit modules for you, so you could just copy and paste them into your Metasploit installation, and you can start writing them. So that's good. Speed is not too bad, so don't complain about I can do it right. I can write it faster in Python. You probably can, but I mean, if you use Mona, the results and the reliability of the results is going to be much better than doing it manually. So.
And we're also, it's actively maintained, so we're working on it all the time.
Yeah. There are also some nice find functions that you can use to do like recursive searches for pointers that will help you writing exploits for vtable and function pointer overrides. So that's kind of nice. That's kind of neat. And some other functions like you can assemble instructions to opcode. You can look for the modules that are loaded in the process and see all the module properties. All kinds of stuff that you can do with Mona. But what is more important in today's exploiting is that we'll have to bypass DAP. So we'll need to have a way to deal with that. And a typical process to bypass DAP is we'll need to build a set of gadgets, basically build our tool set. We'll need to figure out what API we want to call to either mark your area as executable or allocate some memory somewhere else and then copy your shellcode to it. So we need to figure that out, and we need to figure out a way how to get that pointer in a reliable way. There are a bunch of different techniques to actually write your up chain. If you're dealing with a exception handler, but sometimes in other cases as well, we'll need to find a pivot, like move around on the stack so we can return control to basically kick off our ROP chain. And yes, a lot of pointers, but a lot of pointers means that we still need to have a way to make sure that they don't contain any bad characters. So Mona can help with that. It has a way to generate gadgets. If you run the Mona rob command, it's also going to run rob func, which is the routine that will try to find reliable pointers to one of the interesting APIs that you can use to bypass that. It will also generate stack pivots. So it's going to create a file that shows you if you want to pivot on the stack for that distance, then you can use this pointer because it points to that instructions. So that's kind of good. And of course, you can still use the Mona global options. So if you know that 20, 0, 0A, 0D are bad characters, you could just say, you could just type Mona rob minus CPB criteria pointer bad characters. You specify your bad characters, and it's only going to return pointers that don't contain those bad characters.
So we've got up here next, oh yeah, you can use previously created if it's in your log file. It can search that. So this is the generic process for creating ROP. Memories, we search memory for the gadgets. We put that out in ROP.txt. ROP func also runs that. We also look for suggestions and stack pivot out of that gadgets file. When all those things come together, we own. Yeah. So we've kind of built a new mascot. Oh yeah, we've got a database out there of some working ROP chains, semi-universal, so check those out. They don't take much work.
So if Mona can do all of that, we were kind of thinking, well, what if we could do something like this, like Rob the Builder, or in other words, SpongeBob SquarePants. Can we automate it?
The answer is yes.
Yes, we can. So what Mona Rob also does, it's able to take all that information, basically take your Rob gadgets and the stack pivots and all the information, and it's going to build a Rob chain for you if it's able to do it. So functionality has been there since June. It's using the push AD technique. I received a lot of questions about, hey Peter, what kind of intermediate language do you use to basically map your gadgets into the logic that you'll need to build the actual chain? And I didn't really have a name for it. It's something that I wrote myself. I kind of figured out a name this morning. I just called it assemblish because it's just like inc EBX, and I just use that as my intermediate language, or move the register to another register. So I just converted it to English. So I'll just show the last demo. It's a Wireshark bug. You just broadcast a deck packet on the network, and you can own everyone who is sniffing you. So quick demo. So what we'll basically do in this demo, there's already an existing exploit for this bug. I wrote the exploit somewhere in April, I think, and it has a, we'll just see in a minute. So the exploit section, it has Rob gadgets. So this is the Rob chain that I wrote manually. I'll just remove it. I'll just rip it out. So on my, this is just a Vista box, but it works on Windows 7 as well with ASLR and DEP enabled. I'll just attach Immunity Debugger to Wireshark, and there it is. And I'm going to run Mona Rob. I already know that I only need like 4 DLLs, so I figured it out in advance just to speed it up a little. So I'm just going to run it. This entire process takes about 7 minutes. So I kind of cut out a little piece from the video. You'll see it blur away and then come back. There it is. So boom, 7 minutes later, there it is. See?
Which is a lot less than the hours this used to take.
Yeah. So if you now look at the logs folder and see what it has created, there's a bunch of files in there. The first one that it creates is the rob.txt file. Those are just all the gadgets. And it's going to just list them one by one. So pointer, this is the gadget. Pointer, the gadget, and every time you see the name of the module and the module properties that may be important for you. So, and second file is the stack pivot. So we just see the distance that we can jump using the pointer, and those are the instructions. And it will find gadgets that contain other instructions, but they don't break like the flow of that pivot. So it will list all the pivots that you can find in those DLLs. Then the ROP suggestions file, that is basically my little assemblage intermediate language. So this is nothing more than just grouping some of the instructions together. So you can easily say we want to find like push AD. You could just search for it. Yeah, there it is. So that is my intermediate language. It's no big deal. And then finally, what is even more important is ROP chains. So Mona is going to try to create up to 4 chains. It will try to create a chain for the virtual protect technique. So that's the first one. There it is. And it created the entire chain. And as you can see, it's Metasploit friendly. You just need to copy and paste it. And that's what we'll actually do in just a second. So it does the same for anti-set information process, set process dep policy, and virtual alloc. And again, Ruby syntax. So, in the beginning of this demo, we ripped out the ROP chain in that exploit. So I'll just copy this one that it's just created. I will paste it in. There it is. Oh yeah, tabs, not spaces. I mean, we'll just save the file and we'll run it. So we just make it list on the network. I already set up all the parameters. So it's just going to put a packet on the wire. It's going to broadcast a packet on the wire. And we'll use the reverse interpreter. This is the interface that it's going to put the packet on. So see, I called it universal, but I tested it. There we go.
We got an interpreter.
And if you insist, yes, we can run calc too. So there it goes. Questions?
I think we're probably going to have to take that outside, yeah.
Does the Mona have any support for Windows?
I haven't tried it yet. Well, it does not support the protection bypass itself because I haven't tried Windows 8 yet. But I'll work on it. If it can be automated, I'll implement it.